You ever see a strawberry in the grocery store and it's just perfect? And you stop and think, wow, this thing traveled thousands of miles to get here. Well, that journey is a high stakes race against time. Today, we're going to look at how a virtual world, a digital copy, is helping solve a very real problem: keeping our food fresh.
Right, that's the big question, isn't it? Because behind every single piece of produce, there's this complex journey where every second, every degree really counts. One little mistake, one delay, and you've got spoilage and waste. So the challenge is making that journey as fast and efficient as possible. The whole system is basically one big race against spoilage. The secret weapon is something called the cold chain. But as some researchers found out, this chain, well, it often has some really weak links.
So, what exactly is the cold chain? Think of it as the unsung hero of our food supply. It's an unbroken, temperature-controlled chain that goes from the farm to the processing plant to the distribution center, all the way to the store. Everything is kept cool to stay fresh. It's absolutely critical.
But here's the thing. When researchers took a close look at one specific distribution center, they found it was riddled with problems. The layout didn't make sense, the processes were way too complicated, and there just wasn't enough automation. All this meant that people and products were moving around way more than they needed to, burning through precious time.
Now, you can't just start knocking down walls or buying new million-dollar machines in a real functioning warehouse to see if it works better. That's a huge risk. So the researchers did something really clever. They built a perfect one-to-one digital copy of the entire warehouse on a computer.
And that's the magic right there. It's called a digital twin. It's like a risk-free virtual laboratory where you can experiment, move things around, break stuff, and find the absolute best solution without wasting a single dollar or a single strawberry.
And this wasn't just some video game. The team used some seriously powerful simulation software called Flexim. They followed a super rigorous process. First, they surveyed the real warehouse, collected mountains of data on every single operation, then built the model, and this is key, they validated it to make sure their digital twin behaved exactly like its real-world counterpart. Okay, so with their virtual warehouse up and running, the first thing they did was just hit play. They ran a simulation of the warehouse's normal, everyday operations. The whole point was to find the traffic jams, the log jams, the exact spots where the system was grinding to a halt. And almost immediately, they found a huge clue. A key piece of sorting equipment was sitting idle, doing absolutely nothing for over 60% of the day. It was just waiting for work that wasn't getting to it. The next clue? The conveyor belt that was supposed to take goods away from that sorting area was blocked almost 40% of the time. So you have a machine waiting for work and then a traffic jam right after it. Total gridlock. But this was the real shocker. The person operating the storage area was idle for over 96% of their shift. They literally had almost nothing to do, which pointed to a massive breakdown in the entire flow of goods. So what did all this add up to? Well, here's the big picture. The distribution center was only successfully processing about 38% of its goods on time. The rest, over 60%, were getting delayed or blocked in the system. That's a staggering amount of inefficiency and potential spoilage. But here's the beautiful part about the simulation. It doesn't just show you what's wrong. It helps you figure out how to fix it. Using all that data, the researchers could pinpoint the exact changes they needed to make to unclog the system and draw up a blueprint for a way more efficient warehouse. And the plan they came up with was incredibly specific. We're talking add one vehicle over here, add a processor over there, replace that idle operator with a forklift to help out elsewhere. They even changed the software rules for storage and added a whole new staging area. These weren't guesses. These were targeted, data-driven fixes. So, the team programmed all these changes into their virtual warehouse. They created a new, optimized digital twin. Then, with all the virtual upgrades in place, they held their breath and hit play one last time to see what would happen. The results were, well, they were unbelievable. The turnover rate, that's the speed at which goods get through the system, for refrigerated and frozen goods jumped from a dismal 10% to almost 90%. That's not just an improvement, that's a complete transformation. And maybe most importantly, for those highly perishable items, the ones with a really short shelf life, the success rate shot up from 68% to over 91%.
In the real world, that means more fresh food getting to stores and a massive reduction in waste.
So, what's the bottom line here? This wasn't just some interesting academic exercise. By fixing the system in the virtual world first, the researchers created a tested, validated blueprint for success. Now, the real-world warehouse can make these changes with total confidence, knowing they're going to work.
And that kind of leaves us with this really cool question. This technology solved a huge problem in food logistics, but what else could we use it for? Think about it. Chaotic emergency rooms, city traffic grids, complex manufacturing lines. If we can build a perfect virtual copy, we can almost certainly find a better way to run it. What complex system do you think we should fix first?